In this problem, we are given this system AX equals B. We want to determine if this equation is consistent for all possible B1, B2, B3. Well, so to answer this question, that means B1, B2, B3, they are arbitrary. In order for this system to be consistent, we should not have any free variable. That means we must have three pivot positions, right? And then, well, so the first question is pretty easy to answer by RREF this guy to see if there are three pivot positions. Now, if the equation is not consistent for all possible B1, B2, B3, then we want to give a description of the set of all B. This is a vector B, for which the equation is consistent. So that means if it is not consistent for all possible B1, B2, B3, then it should not have three pivot positions, which means if you RREF A, there are at least one row that will be 0 on the bottom, and you also want to make sure that the last column must also have a 0 entry at the bottom. Otherwise, it would not be consistent, right? So we want to find all B so that it is consistent. Now with that means we have to do some RREF by hand, and this is what we are going to do. Okay, so I'm going to copy down the matrix. We don't need to completely RREF the matrix, we just need to reduce to echelon form. So the first one is I'm gonna replace my row 2 by adding twice of the row 1, right? So that to eliminates these 2. So I'm gonna say row 2 plus 2 row 1. Now for the row number 3, I will have to this one minus 3 times this guy, so R3 needs to be updated by R3 minus 3 times R1. The first row will be the same. Oops. This is B1. The second row, this is 0. Again, keep in mind this plus twice of this guy, right? So 5 plus twice of negative 3, which is 5 plus negative 6, negative 1. And then this plus twice of that. So negative 1 plus 2 is going to be 3. And here this is B2 plus twice of B1. The third row will be R3 minus 3R1. So 3 minus 3 times 1 is 0. Negative 6 minus 3 times, which means negative 6 plus 9, right? Negative 3 times negative 3 becomes positive 9, so we get 3. The next one is negative 3 minus negative 6, which means negative 9. Here we should have B3 minus 3B1. Now, the next thing I would like to do is to 0 this entry by using my row 3 plus 3 times row 2. The first two rows will be the same. The last row will be 0, 0. And then this plus 3 times this, which is 0, right? So it's going to be 0. And then the last entry, I need more space. It's going to be B3 minus 3B1 plus 3 times B2 plus 2B1. This is original entry. We need to add 3 times the row 2. Now, in order for this to be consistent, you must let this be 0. So therefore, the equation, well, I'm going to answer the question now. determine if the equation is consistent for all possible b1, b2, b3. The answer is no. Because of what? We have only 2 pivot positions for the matrix A, only 2 pivot positions, right? So because A has only 2 pivot positions, and then I need to answer the second part. The question is not consistent for all possible b1, b2, b3. Then what must be the b so that the equation is consistent? So here this has to be 0. That means this has to be 0. So let's simplify that. b3 minus 3b1 plus 3b2 plus 6b1 has to be equal to 0. And then let's combine these two together. So 3b1 plus 3b2 plus b3 equals 0. So that's the condition that so when b satisfies this equation, then ax equals b is consistent.